Hi class. So everything is new and we're still getting used to our classroom and the amount of time we have, and I'm adjusting to that just like you are. And part of the adjustment is we do need to cover 3 lessons a week. So we didn't get to 1.5 in class today. I need you to do 1.5 at home on your own. So we're going to do this online lesson. Now you do need to print the lecture notes. That will help you follow along with me. I also grade these notes. And so if you go to Mom, you'll see right here a little link that says print. So click on Tuesday, and right here it says click, and it'll lead you to a download option. And so right now it is downloading. In Windows here, I have to click download, and once I might be able to print right now as well. But that way your computer will be slightly different. But you download the PDF one way, and then you print it when you're able to. After you've downloaded it. Okay, so you got these notes here. You may need to pause the lesson so you can get the printout, and when you're ready, come back. All right, I'm assuming you paused and were able to get the printout and you're ready to go. And 1.5, we're going to look at 2 big things. One thing is the square root, and the second big thing is how to classify numbers. And so let's jump right off here and talk about squares and square roots. So first, there is this thing called an exponent. And we use exponents like this. We have a base to a power. So we might have 7 squared. So the base is 7 and the power is 2. Now what that means is a repeated multiplication. It means 7 times 7. We might have 5 to the 4th power. So the base is 5, the power is 4, and it means 5 times 5 times 5 times 5. Now today we're going to focus primarily on second powers. Now, when you do second powers, you get these certain outcomes. So, if we start at the beginning, I'm just squeezing a lot of ideas into this little bit of space here. But if you take the first number 1 and you do 1 squared, you get 1. 1 is a perfect square because 1 times 1 is 1. If you take 2 squared, you get 4. 4 is a perfect square number because it's 2 times 2. And then 3 squared. 3 times 3 is 9. 9 is another perfect square number. So I'm going to list several perfect square numbers, and I want you to memorize these. You'll use them a lot, so it should start coming to you pretty quick. But if you know like the first 12 perfect squares, you may know them already. It helps you so much when we do square root math. So after 9, there is the 4th number squared. 4 times 4 is 16. Then the 5th number squared. 5 times 5 is 25. 6th squared is 36. 49. 8 times 8 is 64. 8 times 8 is 64. I had to make a little typo correction. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And then 12 times 12, 144. Now there's a bunch more perfect squares. This goes on forever. But if you've memorized that list, for Algebra 1, you're going to be in great shape. You'll be able to do a lot of square roots. And now, so a couple of little insights into this discussion. So we have this, let's pick 7. 7 to the 2nd power. That's how we say that. 7 to the 2nd power. But we also say 7 squared. 7 squared is kind of like a nickname for second power, and it's because 1, 2, 3, 4, 5, 6, 7. I shouldn't have picked 7. It's going to have a lot of dots. 1, 2, 3, 4, 5, 6, 7. And if I make all these dots, 7 rows of 7, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 7, 2, 3, 4, 5, 6, 7. So I got 7 rows of 7 dots. It makes a square. And it happens to have 49 dots. So we call 49 a square number, or a perfect square. And we can do this with 9, 3 rows. 1, 2, 3, 1, 2, 3, 1, 2, 3. It's another square, has 9 dots. So 9 is a perfect square, 3 by 3. Anyways, that's where some of the vocabulary of this whole thing comes in. Now, why are these numbers so important? Because we can reverse the second power with a square root. So it doesn't say that in here, but loosely thinking, the square root reverses second power. Now that's not a perfect statement, but it's an idea that I think will help you. So formally, a square root is a number. The square root of a number is a number which, when multiplied by itself, gives the original number. The words are kind of complicated, but the math is not too bad. If a equals b squared, then b is the square root of a. So and we use this symbol here. That is the square root sign. So if I say a equals b squared and I take the square root of a, that means I'm also taking the square root of b squared. Now this is that idea. The square root will reverse the second power, and that equals b. So here's what I want you to think about in your mind. If you have b squared is kind of like b times b. So if you have two factors of b times c, and you take the square root of that, you're taking the square root of b squared, which is b. So in your mind, you think this. So I kind of wrote that down here already, but let's do an example to practice a little bit. So I'm going to cover this. Let's say we have to do the square root of 25. Now that's one of the powerful things of memorizing all these perfect squares. 1, 2, 3, 4, 5. 25 is the 5th perfect square, so the square root of 25 is 5, because of 5 times 5. So in your mind, what you think, you don't write this down. When you're doing the square root of 25, you don't write this down, but in your brain, in your mind, mentally, you think, oh, square root of 25 is square root of 5 times 5. So if you have two factors of 5 and you do that square root, that equals just the normal number 5. So that's what we're doing with these perfect squares. The square root of 121. Now in our mind we think, wait, 121, oh, what is that? That's 11 times 11. So the square root of 121 equals 11. Done. You don't have to write anything else out. You can just take the square root of these perfect squares and put down the answer. Now you do have to memorize them and kind of get used to them, but I want you to be able to do all these square root answers just by heart. So square root of, let's say, 81, oh, that equals 9. Now, an important one I didn't put in the list is the square root of 0. What is the square root of 0? Well, if we think about, can we take 0 to the second power? If we do 0, 0, well, yeah, 0 times 0 is 0, so we could think of it as like a perfect square. So technically, 0 is one of the perfect square numbers. It just doesn't make a square because there's no dots. But this, I'm over-talking it, over-explaining it. Square root of 0 equals 0. Just keep it real simple there. Okay? Now, all of these square roots come out really nice. These are all nice. I say nice because we can do the square root and we get a nice, easy answer. Now, most square roots are not nice. They do not have easy answers. So what we want to look at next is how can we simplify square roots? There is a long way to simplify square roots and a short way. Now, the short way of simplifying square roots is good for people who have memorized the perfect squares and they have good number sense, which means they can kind of look at a hard number, say like 50, and break it down really quick with only the perfect squares. Now, people who, not everybody has that number sense. Some people have to kind of work at it more, and it's safer if you don't have that number sense. Now, that number sense will develop as you practice more and more. You'll start getting that number sense, and you can switch from the longer way to the shorter way once you start getting the number sense and know how to use these. But if you don't quite get it right off the bat, the long way works too. Now, when I say long way, it's not that much longer. It's just a little bit longer. But what I want to do is I want to simplify square roots that are not easy. For example, the square root of 18. Now notice 18, it's not one of the perfect square numbers. 16 is, 25 is, but not 18. Now the square root of 16 is 4, and the square root of 25 is 5. The square root of 18 lands in between it, so the answer for this is somewhere in between 4 and 5. But we don't know what it is. So we're going to learn how to simplify this square root, and there's two strategies. We're going to take 18, we're going to break it down. Now we're going to say, oh, 2 goes into 18. 2 times 9. Now that's a perfect square number, 9. But some of you aren't quite following this whole thing, so break it all the way down. 9 is 3 times 3. So the square root of 18 equals 2 times 3 times 3. Now notice 3 times 3 is a squared number. And if you want, you don't have to, but the square root of 3 times 3 equals the whole number 3 all by itself. That's what we learned right here. The square root of a b times a b, square root of that answer is just a regular b, no square root. But this guy is left. And the square root of 2 is not a nice square root. It doesn't have an easy answer. 2 is not one of the perfect square numbers. I don't have 2 up here. I can do the square root of these numbers, but I can't do the square root of any of the numbers in between. Like between 1 and 4 is 2. The square root of 2 doesn't have a nice answer. And this is kind of like fractions. When you get a fraction with big numbers, you reduce it to lowest terms. When you get a square root with big numbers, you reduce it to lower square roots. This is a simplified answer. It's an exact, pure answer. Okay, now if this way makes sense to you, use it. If you are good with number sense, you may like this other way. So I'm going to change colors and do it again. And what we want to do is simplify a square root of 18, and the only numbers that simplify easy are these perfect squares. So I'm not going to try 2. It's not in my perfect square list, so I'm going to try 4. Does 4 go into 18? And use your calculator if you need to, but the answer is no. Go to the next one. Does 9 go into 18? Wait, 9 is a perfect square number, and it breaks down 18. So what I'm going to do is factor out 9 times 2. Now the reason I'm using the 9 is because this is a nice square root. This one is not nice. So the square root of 2 is stuck. But the square root of 9 is not stuck. I can simplify that. And the square root of 9 is just a whole number 3. 3. No square root on it. It's square root of 9, just a regular whole number 3. Now that is timesing. This square root is stuck. I can't do a square root of 2. It doesn't have a nice answer. So I'm just going to leave it square root of 2. That is the simplified reduced square root answer. So I'm getting the same answer whether I factor all the numbers or I factor only perfect squares. It works out the same either way. I want to do a couple more of these. And let's do the square root of 50. Now, if we're going to do this the longer way, it's not that much longer, but it's a little extra step. You have to completely factor. Now, I'm not going to go slow on this, but you have to break down 50 all the way. So I'm just showing you real quick. I broke down 50 by factoring it. 5 times 10, and the 10 I can break down a little bit more into 2 times 5. So I'm going to use all these factors to do the square root of 50. Now I'm going to put them in order. There was a 2 times a 5 times a 5. Okay, so that's completely factored, and I see a double factor of 5, 5 times 5, which has a nice square root. A nice root. Now the square root of 2 doesn't. I cannot take the square root of 2. That is stuck. But the square root of 5 times 5 is 25. The square root of 25 is 5. And that's this idea here. Square root of b times b is b, or the square root of b squared is b. So this problem is going to equal the whole number 5, because the square root of 5 times 5 is square root of 25, which is 5, times the square root of 2, which is left. I cannot do the square root of 2 and get a nice answer. So I'm going to times it by the square root of 2. So this big square root, square root of 50, reduces down to a whole number 5 times square root of 2. So I've broken down the big square root into a smaller square root. Okay, same plan, same problem, but let's try it again with the perfect square method. Now, I don't mind which method you use, as long as you're good at one. But I think it's a little shorter to do this perfect squares. So you factor only perfect square numbers. So I would not even think about 2 for the 50, because 2 is not a perfect square number. I only think about these numbers up here. Now 1 doesn't break it down, so I'm skipping 1, but 4. Does 4 go into 50? And you may have to use your calculator to try. But 50 divided by 4 doesn't work. 9, does it go into 50? Nope. 16, does it go into 50? Nope. 25. 25 goes into 50. So I'm able to factor it here into square root of 25 times 2. Now 25 is a perfect square. This has a nice square root. Square root of 2 is not nice. So this square root of 2 is stuck, but the square root of 25 I can make simpler. Square root of 25 is a whole number 5. Notice I do not have a square root on it, because square root of 25 is 5. I'm done with the square root, but I'm not done with this times square root of 2. That part is stuck. So I'm still stuck with the square root of 2 under the square root symbol. And that is using perfect squares to simplify them instead of completely factoring to simplify them. Okay, let's try another here. Can make some room. And try it again, this time with 80. All right, so you'll need some scratch paper. I was going to save time and not do it, but I can do this one pretty fast. 8 is 2 times 2 times 2. And 2 times 2 times 2 is 8. 10 is 2 times 5. It's a little sloppy, but I went fast. So it's 2 times 2 times 2 times 2 times 5 is 80. So I've completely factored it. 1, 2, 3, 4, 2, 2, 2, 2 times 5. Now, hey, if you have two factors of a number, the square root does that nice. But there is another pair. So the square root of this pair is nice, and the square root of that pair is nice. So this answer, the square root of this pair, square root of 2 times 2 is 4. The square root of 4 is just a whole number 2. It's just a nice whole number 2 for the square root of this pair. The square root of this pair is also 2 again. So there's 2 of these nice answers. These are 2 whole numbers. There's no square roots on them. The square root of these 2 makes 1 factor of 2. The square root of this pair makes 1 whole number factor of 2. Now the square root of 5 is not nice. That is stuck. So this simplified sum of the square root. This one gave a whole number 2, that one gave a whole number 2. So I have a whole number 2, and a square root of 5. But because these are both whole numbers, I can multiply and get 4 square root of 5. Done. Okay, let's try square root of 80 with the slightly shorter method. So we're going to take 80 and we're going to factor only perfect squares. So I'm not going to look at 2 at all, because 2 is not a perfect square. I'm not going to look at 5 or 7 or 11. I'm only going to look at these numbers. Will any of these numbers break down 80? Now, if you need to, use your calculator. See if they will work. Turn it on. Clear. Clear. Okay, so I'm going to take 80. I'm not going to divide by 1, because 1 is going to divide it, but it doesn't simplify it. So I'm going to divide by 4. Okay, it works. 4 breaks it down. But wait, don't always go for the first smallest number. You want the biggest number. The bigger number you can get, the more it'll simplify. So we don't want to just go with 4 times 20. That is nice, but maybe there's a better number. So let's keep checking with the other perfect squares. Let's try 9. 80 divided by 9. Nope. Let's try the next perfect square number. 80 divided by 16. 5. 16 times 5 is 80. And 5 is really small. There's no extra factors in it. So here we have 16 times 5. This one's nice, and it's better because it's bigger. I'm breaking it down more. 20, I would have this left over, square root of 20, and I'd have to do extra work to break that one down. So that's not our best play. Find the biggest perfect square number that goes in this case it's 16. So we're going to have the square root of 16 times 5. And we like this because, oops, this is the wrong color, it's supposed to be green. Square root of 80 is square root of 16 times 5, and the square root of 16 has a nice square root. In fact, that nice square root of 16 is the whole number 4. There's no square root on it. It's just 4. Square root of 16 equals the number 4. But there's some leftover, times 5. But the 5 is still under the square root. There is the simplified answer. It's the same as we got over here. They're just slightly different methods. And like I said, I don't care which method you pick. Just get good at one